Good morning. It's my pleasure to introduce Michael Kininmonth as our key speaker this morning. Michael has spent 42 years working in textiles, from wovens and knits to non-woven composites to apparel fabrics and medical textiles. He joined Cortals just after the launch of TENCEL. Michael is currently working as the Business Development Manager for Lenzing Fibers, focusing on sustainability and denim products. Michael resides near Nottingham in the UK. Welcome, Michael.
Hello there.
And we also have Begona Victoria from Jeanologia joining us today. Many of you know Begona as the person with Jeanologia who is helping to build more sustainable garment finishing techniques. She also promotes the use of Jeanologia technologies as key elements towards a more sustainable denim finishing industry. Welcome, Begona.
Hi, hello, good morning.
Okay, take it away, Michael. Thank you, Karen.
Thank you.
Okay, thank you. So it's a good afternoon from here in Spain. Lovely day again in Spain, 4 o'clock in the afternoon. So I'm going to give you a little background to this presentation. The relationship between TENCEL and Jeanologia goes back to around 1994, and since then they participated in many different projects together. Those projects have been a combination of technical solutions and product development. And I would say the relationship is such now that we're both highly familiar with each other's know-how, and working together has become almost second nature. The unique selling point of TENCEL has always been its strong environmental story. However, this USP didn't count for much in the early days of TENCEL. Resulting from years of experimentation, we've realized that timing is a major factor in all things research and development. And so this webinar is an example of such timing. Traditionally, fashion laundry has been seen as a low-tech industry driven by manual labour and rather crude finishing techniques. However, the apparel industry is starting to turn to digital technology, not only to reduce its reliance on workers, but also to drive new product development, new environmental thinking, and create beautiful products previously not achievable by conventional methods. As Jeanologia have developed their business to become the leading thinkers and suppliers of sustainable laundry machines and techniques, new opportunities have arisen with TENCEL. This webinar documents the history of laundry developments and tries to contextualize the advantages of adopting the new laundry technologies in conjunction with the latest TENCEL fabrics and garments. So some years ago, there was a feature on the BBC TV magazine programme introducing the subject of sustainability in fashion. And the feature began by interviewing a so-called textile specialist to discuss the eco-index that she had personally been developing. A camera shot switched to a young woman clutching a pair of baby blue denim jeans in both hands. She proceeded to caress them gently against her right cheek, explaining that they were made of 100% cotton, which in itself meant that they were totally natural. She continued to extol their virtues, such as they felt extremely soft and comfortable, and finished by saying that in terms of her self-generated eco-index, cotton denim jeans were classified as a 9 out of 10, 10 being the best score. This feature highlighted the general ignorance and ever-present ingenuous view that exists around this ubiquitous product area. Of all the categories in modern apparel, denim jeans and the denim industry that produces them has probably been guilty of some of the worst environmental excesses ever, from the use of conventional cotton fibre through to disposing untreated effluent directly into waterways from commercial laundries that process 95% of all denim jeans manufactured. Looking back today, attitudes to cigarette smoking, it is somewhat shocking to us. It seems impossible that people could have been so blasé about the risks of smoking pose to their health. However, I do feel that history will judge the denim industry in the same way. Thankfully, evidence against certain practices have been building for some years. Here's an example of a report from Greenpeace called Dirty Laundry, which you can seek out on the Greenpeace website. And many of you may know about banning of sandblasting on jeans by a lot of the leading brands. It was found that large amounts of silica dust generated during the process could cause silicosis, a potentially lethal pulmonary disease, as workers inhale the tiny particles of silica. Thankfully, countries such as Turkey and most of the leading brands and retailers have now banned this use in their supply chain. So, for you that are less familiar with laundry, here's a presentation of a slide that actually tries to show you exactly what goes on in the laundry. The denim jeans industry is unique in that the cut and sew process is not the final stage of manufacturing. The finishing stage has developed into a major industry in itself and is primarily designed to bring a particular unique aesthetic to the final garment. The finishing of garment begins with the finishing of a garment brings with it major added value, but also the potential to cause environmental or human harm. Broadly, this is what happens within a commercial fashion laundry. You have washing, you have dyeing, and you have finishing. And all of them are there to give you certain particular end users. So, for instance, hand improvement might be an enzyming process, a softening process, a tumbling process. You have colour removal through bleaching. You have de-hairing through enzyming. You have different processes to cause distress. You can add colour rather than take it away with dyeing. And then there's always the imparting performance, which might be something like wrinkle-free or coating or repellency. So if you look at the history of laundries, and I don't want you to keep me exactly to these dates, during the 1980s, the laundries really were on the periphery of the textile industry. A lot of the production was done in institutional laundries, such as those that actually washed bed sheets or towels for hospitals or hotels. And at the time it was seen as a passing fad, and most of the laundries just had developed their own processes. And there was a lot of black art involved. During the 1990s into the 2000s, the industry developed very quickly. A lot of dedicated commission processors started up. There were a lot of vertical companies, so garment makers then that had laundries themselves, and it became a leader in product development. Since about 2005 onwards, there has been really the next stage of evolution or revolution, you might say. There's been a lot more focus on sustainable processing. More latterly, we've had a real change away from what I'm calling analog to digital techniques, and there's been a much more greater focus on product development with environmental responsibility. So where we are today, we are really focusing on laundries with two targets in mind, sustainability and technology. In 2015, I read a headline and it said, "It's the second dirtiest thing in the world and you're wearing it." So this particular feature was talking about how polluting the apparel industry was, only behind the oil industry in terms of pollution. Now, I don't know if this analogy is absolutely accurate, but we know as an industry that there has been a need to address past ills. Sustainability is a real driver in this industry, and technology has been the real driver to achieve more sustainable products. The way a product is made can reflect either well or badly for the image of a brand. So today it's not just about aesthetics, but it's also about manufacturing technology. It's not just about the look of the product, but it's also about how we produce the product. And cost efficiency is especially about the way we manufacture. There is no doubt that technological developments are helping garment companies differentiate their products and operate more efficient and cost-effective supply chains, which makes it imperative for manufacturers to remain in touch with what's new. There is a significant evolution in the jeans industry, and one of these evolutionary technologies is laser marking. So, one of the most significant and successful technologies to be introduced in the commercial fashion laundry in recent years has been the use of lasers. With the advantages of relatively high speeds and productivity, plus the possibility to replace techniques such as sandblasting, laser marking is a very attractive technology for both environmental and ethical reasons. Laser marking is used to obtain localized color removal in pre-dyed fabrics, thus creating the vintage look on denim garments, efficiently and effectively on an industrial scale. However, not all fabrics react in the same way to laser marking. The differences are the result of many different factors, which include the fiber type, the yarn type, the twist of the yarn, the dye type, the penetration of the dye, the fabric structure, and many more. Therefore, it is necessary to analyze every fabric to understand the reaction that they will have to the application of the laser, and to subsequently be able to establish the ideal process parameters in order to obtain the desired effect on the garment. Fabrics that contain TENCEL have the above desired characteristics and are the perfect fabric to work with laser no matter the colour, the shade and the density. This has come out through many studies we've done with Jeanologia, and that is why we are calling TENCEL a light sensitive fibre. So how does laser work on the fabric? So the energy provided by a laser beam has two effects on dyed fabric. First, there is the thermal effect of the laser, which sublimates the dye stuff. Sublimation means there's an instant change from a solid to a gas, and so the dye is removed in this way, and effectively it bleaches those areas that it's contacting on the fabric. Secondly, there's a thermal effect on the fabric itself, and this is the burning of the surface of the fabric, eliminating colour fibres and revealing the undyed fibre below. This superficial burning of the fibres leaves an area of ash, which on cotton gives you a brown colour. This is then removed subsequently by rinse washing. The dyeing process of denim yarns can include additional dyestuffs to indigo, such as sulfur dyes, commonly sulfur black. Each dye has its own molecular structure, and so reaction to the thermal effect of laser will be different for each dyestuff. So now we're going to outline what is called a light sensitive test, and hopefully this outline will give you a better idea of how laser works on fabric. So this test has been designed to quickly analyze the way that a fabric reacts to a laser marking. It is then possible to design at washing and finishing recipe to give the desired look and feel, but at the same time reducing water, chemical and energy consumption. So here is the first part of the study. So this part of the study is done on the original raw material. On the left-hand side, you have markings that are there to create a vintage design at different intensities of laser. It is given what is called a single or a simple marking, and then another layer of marking over the top, which means double marking. So top center, this is to analyze how the fabric is damaged, how holes are created. Again, this is by different intensities, and this part of the laser process is called a light ripper. So Light Ripper is the brand of Jeanologia for this particular process. To the right-hand side, you have grayscales. This demonstrates the whiteness level and the gradation level at different intensities. And bottom center, this is another tool called Light Scraper, and this one is there to recreate virtual slubs, virtual cross-hatching and virtual ring spun looks on fabric bases. There's a second part of the test that's carried out after those pieces are washed. Here on the left-hand side we have a tool called the light PP spray. So PP stands for potassium permanganate. Those of you familiar with the laundry will know that potassium permanganate spray is used to bleach out certain areas of indigo from the garments. So this is the light PP spray tool to check the permanganate spray substitution. And then there's a second light ripper tool in the middle. So this is to check how easily holes are made on wash fabrics rather than raw fabrics. So I'm just going to give you a video now, and which will show you basically this happening on a piece of fabric. So we'll just go through the test very slowly for you to understand. So the first markings on the raw fabric are the vintage effect markings. So this first part of the test creates a small vintage design as a visual reference. Vintage designs are done at different intensities with simple and double marking, and this enables the analysis of the fabric in order to develop efficient washes for production and the ability to reproduce it. Again, damages. So this is through the light ripper option, and this checks the weft strength of the fabric. So if you are making damages, the idea is that you will burn away the warp threads but leave the weft threads intact. So you need to know at which intensity this is going to happen. So grayscales is about understanding the whiteness level and the three-dimensionality effect of the fabric. So you need to understand at which intensities that you get this. And finally, you have the light scraper tool. This is one of the latest revolutionary tools developed by Jeanologia, and it's creating these virtual fabric effects, which actually gives you many options on the same base fabric. So in effect, it also eliminates hand scraping, for instance. So these tests are normally done on three different fabric bases, and then each base is given a particular wash. One is given a simple enzyme wash, another one is given enzyme wash and an ozone process, and another one is given an enzyme wash and a bleaching process. Then, on those wash pieces, you have these extra processes. So one of them is this light PP spray. And here is a video showing what happens. Or maybe it isn't a video showing what happens. Excuse me. So there you see an overlaying of what has been on there already. And PP spray is used very widely in the laundry industry. And in effect, it was the next on the list really to see if this could be replicated, because potassium permanganate spraying is not very pleasant for the people who are doing it. So this is really a step forward in development of laundry. Finally, there's another damaging test here, because to understand if a wash fabric will be damaged at what intensity. Again, I'm going to show you a video, hopefully it will work. So sometimes the damage done on the raw fabric is then damaged even further in subsequent washing. So a lot of the users of this technology prefer to do damage on washed fabric or washed garments, because then they know exactly that that damage is going to be the damage that ends up in store. So it gives you the options of damaging on raw fabric or on wash fabric. So here is just a summary of what I've just talked about. So you have the entire test there. You have the single and double marking, the vintage marking. You have the potassium permanganate spray effect over the top, light ripper for damage, light scraper for fabric effects, and you have the grayscale for whiteness. Now, you can, if you wish, also have this scoring analysis. So you have whiteness level, which is analysed at 0 to 5, damages 0 to 3, visual evaluation 0 to 3. So analysis 1 is raw fabric, analysis 2 is wash fabric. So you can have up to 15 of a total. And here gives you a broad outline of what that might mean. So a fabric that has a score of 10 to 15 will be considered as a light sensitive fabric. This means that it has the possibility to get natural results of local fade down effects, whiteness levels, character fabric effects or damage with laser technology only. No need to combine with traditional laundry processing. A score of 5 to 10 points means that it's possible to process garments only with laser technology. However, the results can be improved combining the traditional dry techniques such as hand scraping, grinding, brushing, and local applications of chemicals. 5 and below means it'd be necessary to combine laser markings with traditional dry techniques and chemicals to obtain a good result. So highest is best. So effective laser marking requires the following. So you want a fabric where you can achieve quick and effective dye removal. You create clear image definition. That image has sharp outline and you have a smooth grayscale transition. So why TENCEL? So we think that with TENCEL you have different influences, not necessarily just one reason. You have a fibre with a perfectly round fibre cross section. You have a fibre with a very smooth fibre surface. You have a fibre or a yarn made from that fibre where mills are achieving a suitably shallow indigo ring dyeing effect. And also probably the most important is that the fibre compared to other cellulosics is rather brittle in terms of physical damage, and I think it's this brittleness with the laser that gives the laser the possibility to create these different effects very effectively. And this has really been borne out with a lot of trials we've done, and we've now produced a manual or a book that demonstrates these different things. So these are just photo shots from different parts of this manual where we are showing effects of photo image reproduction. We show different light scraper effects in terms of warp slub, wet slub, crosshatch, etc. We have the reaction to laser marking in terms of grayscale and whiteness, in terms of vintage effects, in terms of image marking, creating effective definition and fineness of lines, and also in terms of being able to create marking efficiency very effectively. So all these are different sections in the manual, and they are actually pieces of fabric to demonstrate all these different things. In terms of what we've done on a practical basis, our last two garment collections have really tried to demonstrate the effectiveness of laser technology. So here in the next few pages are some examples of what I mean. So for instance, these two shots here are exactly on the same base fabric, two completely different looks using laser. Again, exactly the same base fabric, but two completely different looks again. You can see on the left-hand side how detailed and how fine that design shows on that base fabric. Here, this pattern effect is actually created through making holes in the garment. So this looks like it's a cross-stitch effect, but actually it's by little holes in the garment. Again, this is another one with holes in the garment in with a different effect. This design here is really something that if you were to do on traditional laundry methods, this would be a completely artisanal produced garment. This garment alone would probably take a person maybe 30 minutes, an hour to create. Here you can have the same design on 100 garments, 300 garments, 1,000 garments by just using digital laser effects. On this jean you can see the fine detail there. This is a fabric which is a plain weave, but we've created a crosshatch effect on it. Again, another fine design there, along with embroidery and embellishment. Again, a twill fabric given a crosshatch effect. And there you have a vintage design on a men's jean. And here is a non-indigo example. So here we've made these designs on a prepare for dye base, and then this has been garment dyed on top of that. So please don't only think that this is a tool for indigo. In fact, this particular technology on prepare for dye TENCEL is showing real promise in terms of how it reacts on the garment dye versus other fibers. So we're really going to explore this in the future. And here this shows a couple of garments where we've used the laser to do damage effects on the garments. So, just through summary, what are the advantages of laser technology? I think simplicity is really one of the key areas for laser technology. So one technology, many options. It is able to replace different processes within the laundry, majority of them dry processing, but also some key wet processes like PP spray, stone washing, resination that is used to create 3D effects. And also nowadays this is being partnered with other new technologies such as ozone and e-flow. So you have a digital technology, meaning it's very reproducible, and also the technology is very scalable. So brands can create their own in-house design, and then they can transfer that information directly to a laundry, who can then recreate what the brands have created in-house. Advantages of TENCEL. So we found that TENCEL fabrics act like a photographic paper. It's possible to produce hyper-realistic images, multiple fabrics from one single base fabric, excellent colour reduction, high degree of whiteness, great colour gradation, three-dimensionality is easy to produce, natural blur, and also reduced marking time, giving you higher productivity. And also it's a very good match on an environmental level with laser and TENCEL fibre. What is the future? Where we are today, I think the technology is very well developed. What is not developed is the link between the technology and the fabric bases. Therefore, I think there will be onus on the mills in the future, fabric mills, to understand this technology and work with the technology such that they are developing fabrics that can be classified as light-sensitive fabrics. We do know there are brands out there, and Levi's is one of them, that is now specifying to their supply chain that they want light-sensitive fabrics. And the light-sensitive fabric score that's developed through this particular light-sensitive test. There is a video online if you want to go, and there's the link, and we'll send you the link anyway, that has a commentary against it showing you the light-sensitive test again. There are the contacts at both Lenzing and Jeanologia. And that's the end of the presentation.
That is great, Michael. That's fantastic, Michael. Thank you so very much. The pictures were especially helpful in allowing us to see the true innovation that this displays. And so, Michael, I know that you and the Lenzing denim team will be at Kingpins Amsterdam and Kingpins New York, where people can see this in person, but how else might folks, and particularly in this audience, find some of the TENCEL denim fabrics that you've been showing?
Well, like I say, we are creating this book or this manual. Now this will be all our merchandisers, all our offices around the world will have a copy of this, and people can see it firsthand. We are making extra ones that will be given to certain key customers that we work with. I think the message that I'd like to say today is that fabrics that contain TENCEL, either 100% or majority blends, all seem to have this characteristic that makes them very easy to work with laser. So I don't think it's a case of saying, oh well, you can only use this or this fabric. I think the understanding is that majority TENCEL will work consistently well with the laser technology.
So, Michael, just to follow up on that, we have a quick question from the audience. As you say, a majority TENCEL fabric. Is there a minimum amount of TENCEL that is needed in order to have a light-sensitive fabric?
Well, I think that if you were taking a blend, you would want to have a fabric where TENCEL was mainly on the surface of the fabric. If you had a fabric that is declared as, say, let's say 50-50 cotton and TENCEL, that might be what I call a yarn blend, so 50-50 between the yarn, or a system blend where you have TENCEL in the warp and cotton in the weft. I think we found that either of those have worked well for us. We'll be happy for feedback if people find otherwise, but I would say you're looking for 50% as a minimum.
Okay. And this, Michael, I'm not sure if this is for you or better answered by Begona, but how can the folks find suppliers who are using the Jeanologia lasers?
Well, I think today, talking to the people at Jeanologia, there's a feeling that there's about maybe 25 to 30% of all the leading laundries now have this technology. If people need exactly to understand which laundry in which country, they can contact directly the contact on here for Jeanologia, and they will be able to put them in touch with the regional responsible. I mean, it's not this is not secret information, of course. Jeanologia would love people to know where it is. I think there seems to be a good spread around the world now in terms of the availability. You know, it's not just in Asia, and so I think I would say that today I would be surprised if it's a leading laundry that they wouldn't have this technology.
Mm-hmm.
So
just to say a number, yes, just to say a number that makes difficult to refer someone to a particular place is that we have more than 500 customers around the world. So that's why we think it's better if someone needs some specific information for a certain production area, so they can contact us.
That's great, Begona. Thank you. Michael, maybe can you page up one page that the contact information is shown here for the audience. There we go. Perfect. Everyone else will, by the way, receive this. These folks again you'll get their contact information on the follow-up email that you all get. Michael, have you done any research into the use of chemical boosters to improve the efficiency of the laser effects, and does it improve the light-sensitive fabric score of the material?
Yes, we have been doing some research as well on this area, and if we talk about fabrics that contain TENCEL, so the results are perfectly good without any additional help. So I would say that choosing the right fabric and choosing a fabric that has a percentage of good percentage of TENCEL fiber, automatically you convert this fabric into a light-sensitive fabric.
Great, and I don't know if you're able to discuss this as well, Begona, but what are the pros and cons for the use of chemical boosters in laser applications?
The goods would be that you can have good results in any kind of fabric, so that opens the possibility for fabrics that before were not so keen to be combined with laser technology. So I would say this is the best, the most important issue.
Great. And Michael, I'm not sure this might be for you. Can we substitute TENCEL 1-for-1 with Refibra on this topic, or does Refibra have additional attributes? I might be mispronouncing that.
Yeah, right, okay. So Refibra is the TENCEL fiber that is made that contains recycled content. No, effectively, I would say the market should regard Refibra as standard TENCEL. there is no loss of quality, and refibra really doesn't actually show any physical differences. It is slightly stronger, but in terms of these other laser or things like that, no, it's exactly the same.
Great, and folks in the audience, I have one more question, so if you have others, please do go ahead and send those in. Michael, can you just discuss any further or future developments that Lenzing and TENCEL in particular might be working on that focuses on sustainability?
Everything that we do, we're trying to ally ourselves in terms of sustainability. The area that we are talking about today, which is the denim laundry or the casual laundry area, I think there's a lot of work to do, and I think we're only just at the start of a revolution. And although we're talking about laser today, I think the other technologies coming through hold a lot of potential. In terms of what we're doing internally, from an environmental point of view, I think the subject of coloured fibre is very interesting. So where you're adding the colour or the pigmentation in the fibre manufacturing so that you don't have to do it to yarn or fabric. We've already done a study, for instance, on a product we have on Modal Black, that's given us very good life cycle analysis results. And we've seen a good acceptance of that in the market. We are now looking at other dye stuffs and other colours in that area. There are maybe one or two other things that I can't really talk about today, but they should be coming into the market within the next year. But yeah, for sure, we actually, everything we do, we try and have some environmental slant on what we do. And if I might just talk about Jeanologia, I know today that that is their total focus in the marketplace. Because I've asked them in the last year to do certain garment developments for me on technologies, and they've turned around and said, no, we don't do that anymore. So they are, they are sticking closely to this environmental and sustainable product area for their business as well.
That's great. Thank you for that, Michael. So folks, there's a couple things I want to just remind you of here. For sure, you can see these guys at both Kingpins Amsterdam and Kingpins New York, where there will be, I had a couple questions on this, Michael, swatches available from the light-sensitive laser. You can always get more information on the Lenzing denim blog, Carved in Blue. Michael, if you want to just go back to that page, I will for sure be sending everybody an email follow-up that will have a link to that, so you will be able to see it there. It will also have a link to Michael's YouTube video that he showed, so you have that available, and it will include a copy of this presentation as well as a copy to all the folks that you saw from Lenzing and Jeanologia as well. So you should have, hopefully by the end of the day tomorrow or latest Friday, a good follow-up email with all this information in it. So Michael and Begona, thank you very much for your time. We have come in just under the hour, so well done. That was perfectly timed. I appreciate it. And to the audience, thank you so much for your outstanding questions and your engagement as always. And we will see you on the next Lenzing Denim Teams webinar. Thanks, Michael.
Thank you.
Thank you, bye.